This question is a reference to the idea of perfect square trinomials. And for perfect square trinomials, there's a little process we're going to talk about. But basically, this part right here has the appearance of a perfect square trinomial, and we want to be aware of that. So let's just say that we had 4x squared plus 20x plus 25. So this has the appearance of a perfect square trinomial if you've seen a lot of them. And let's just say we're wondering, is this thing a perfect square? Now, by the way, what's a perfect square? It's something that when you take the square root of it, you get the same number twice, right? So for instance, 20 is not a perfect square because it divides out to something like 4 times 5, among other things. But 25 is a perfect square because you have 5 times 5. So you have the same factor twice. So here, this is going to most likely factor to something with the same factor twice. And let's test it out. Is the first term a perfect square? Yes. And the square root of 4x squared is 2x. So what we're doing right now is the perfect square test. You go through this test and it tells you if something is a perfect square. And if it is, you can also use this to do the actual factoring. So is the first term a perfect square? Yes, because the square root is 2x. Is the third term a perfect square? Yes, because the square root is 5. Is the middle term equal to 2 times each of those square roots? So in other words, 2 times 2x times 5, 2 times 2 times 5 is 20. So 20x, and the answer is yes. So we just passed all 3 steps of the perfect square test. So because that was the case, we know this would factor to 2x plus 5 all squared. And the only variation of this is if you had a minus sign right here, the same exact thing would factor to 2x minus 5 all squared. But in this situation, the first term and the third term will always be positive. So let's do the perfect square test on this part. And before we actually get into that, there's so many minus signs that what we can really do here is just factor out a -1. And if we do that, it'll leave us with positive c squared plus 2cd plus d squared. And we just said that a moment ago, that these two terms, if it is a perfect square, need to be positive. So the trick here would be to factor out that minus sign and get that to work. So in this situation, is the first term a perfect square? Is the first term a perfect square? Yes, it is, because the square root is c. So right now we're just talking about this piece. Is the third term a perfect square? Yes, it is, because the square root would be d. And is the middle term equal to 2 times each of those square roots? And yes, it is. So we just figured out that that whole thing factors to c plus d squared. So let's rewrite it. We have x squared minus 1 times c plus d squared. Now, looking at the question, they conveniently told us here that A is the same thing as c plus d. So we can say x squared minus 1 times a squared. In other words, just x squared minus a squared. And now what is this? This is a difference of squares. Let's take this and bring it off to the side for our example. If you have a difference of squares, that's the idea that something in the format of a squared minus b squared would always factor to a plus b times a minus b. Now we know that to be true because if you FOIL this out, the outer and inner terms of the FOIL will cancel each other, and you'd end up with a squared minus b squared with nothing in the middle. So the difference of squares is definitely a pet favorite topic of the College Board and the SAT. And so what we have here is a difference of squares. It's two perfect squares, just like you have there, with a minus sign in between that makes it a difference. So it's going to factor 2, x plus a, x minus a, and that's answer choice C here.